Hello, a very warm good evening to all of you and welcome to BYJU'S Exam Prep. Welcome to another episode in the series of Explain, where we shall be talking about Indian monsoon prediction. Now, why is it that we are talking about it? That is because recently, Indian Meteorological Department or IMD has come up with its normal forecast for the long period average of Indian monsoon, in a way indicating that this year again we are going to experience almost normal amount of rainfall during the monsoon months. But then this prediction of having a normal rainfall and also the long period average, what do we mean by that? Because when IMD released this information or this forecast, at the same time it also released another piece of information. And that was that the long period average in itself, when it comes to India receiving rainfall, that has been degraded or downgraded. So in this video, we shall try to understand the mechanism of forecasting of Indian monsoon. We shall try to understand what these technical terminologies are and how rainfall received in our country and the subcontinent as a whole has been varying and changing over a period of time. Also, we shall be taking a look at the various different factors which in a way contribute to controlling the onset of monsoon. And thereby, even after the onset of monsoon is regular, there are still 3 to 4 factors which determine whether the rainfall received during the months of June, July, August and September, whether they are above average, normal or below average. So, in this video, we shall try to understand all these nuances and we shall try to understand the mechanism of Indian monsoon in a better manner. So when we talk about Indian monsoon in general, Indian monsoon is one of the most important phenomena not only across the country but rather across the globe. When we talk about the monsoonal rainfall, what is the exact meaning of monsoon first of all? Monsoon refers to a condition whereby there is a reversal of wind. So, if there is a seasonal reversal of wind taking place in any region, we call that as monsoon. Now in India, monsoon has always been a harbinger of good life. Because in India, primarily almost close to 65 to 70% of our agricultural land is dependent upon rainfall. And during these monsoon months, that is during the months of June, July, August, as well as September, the amount of rainfall which is received by the country is very, very important for ensuring normal agricultural output. Now, one question might come into your mind is that Indian agriculture contributes only 15% to our economy. So how come this monsoon becomes so important? So it is not just the agricultural growth which is directly hampered by the monsoonal rainfall. We have to understand that once we have a proper regular amount of normal rainfall received in an area, that automatically has a large impact on Indian economy as well. How is that? So basically, try to understand this. If in the villages and the rural areas across the country, if the rainfall received is quite normal and quite average, then automatically the crop production shall be significant. Crop production being significant means what? It means that the farm income which is generated in the rural areas, that will be higher. Now, if the farm income is higher, means what? People in the rural areas, they will have more money to spare. And that is what leads to an increase in the rural demand as well. Rural demand for all types of products, be it normal day-to-day usage items. For example, you have salt, you have pepper, soap, detergent, shampoo, etc. But at the same time, also other items such as maybe two-wheelers, four-wheelers, machinery, etc. All of that is dependent upon how much income the farmer has with himself or herself. So that is why rural demand is fueled by normal rainfall. Now this rural demand, if it goes up, means what? Automatically you will have more production in urban areas as well. Factories will start producing more. And that is what will bring an uptick in the overall Indian economy. But then it is not only restricted to economy. The rainfall received during these 4 to 5 vital months, these rainfall are responsible for filling up of water storage structures and tankages, as well as for generation of hydroelectricity. After all, if the dams and the storage structures are empty during these months, then that means they would be empty throughout the year as well. It is during these months where the dams, they fill up to their capacity, and that is where we get drinking water facilities, water for industrial supply, water for generation of hydroelectricity throughout the year. So that gives us an idea about how important Indian monsoon is for our day-to-day lives. It is no coincidence that the years when India has received normal and average monsoonal rainfall, those years have brought about a sense of prosperity. Whereas the years where we have had extremely deficient rainfall, those years we have struggled in order to meet our economic output requirement and targets as well. Then that brings us to the point that if Indian monsoon is so important, then forecasting of Indian monsoon should also be very important, so that the farmers get an idea about when rainfall is going to be received. Across the country, the businesses should also get an idea that when you will have these monsoonal months. So that is what brings forecasting of Indian monsoon into limelight. Now this forecasting of Indian monsoon, it is not a new phenomena which has been started recently. It started long back with the help of Henry Blandford way back in 1886. But at that point of time, Henry Blandford, first of all, we have to appreciate that at that point of time, we did not have so much advancements in science and tech, and we did not have so many climatic observatories across the globe. So our understanding for the climate of the world was very, very limited and restricted. So Henry Blandford at that point of time made his predictions and forecast about the Indian monsoon based upon the snowfall received in the Himalayan region. So that automatically gives us an idea that this forecasting and prediction would not have been very, very successful. What was done by his successor, that is John Elliot, was slightly more progressive. John Elliot started considering the pressure and the temperature conditions in the Indian Ocean, particularly in the region around Seychelles, in the region around Zanzibar, as well as Mauritius, and formed an interlinkage with the monsoonal rainfall received in India. But still, that was very much incomplete. The major milestone was achieved when Gilbert Walker came at the helm of Indian Meteorological Department. It was Sir Gilbert Walker who provided an interconnection of 28 different weather parameters and connected them to Indian monsoon and linked them to Indian monsoon, thereby demonstrating that how complicated Indian monsoon as a phenomena is. Since that time onwards, we have been developing and improving our prediction and predictability about the monsoon. Now, we consider various different parameters such as the heating of the Atlantic, Pacific, the polar areas. All of them are included in our prediction which is generated for the Indian monsoon. Now, what is it that Indian Meteorological Department has generated as a forecast? If you look at it, then as per the IMD prediction, we know that IMD actually gives a prediction of normal, below normal, or above normal monsoon in relation to the long period average, or LPA. Now, what is this LPA, by the way? So when we consider LPA, or long period average of rainfall, it gives us an idea about the rainfall recorded over an area over a span of 30 to 50 years. So any region, let us suppose we consider the northern or the northwestern part of the country. let us assume that over the period of 30 to 50 years, on an average, this region receives around 70 centimeter of rainfall during the monsoon months. So 70 centimeter becomes the LPA, or the long period average. As per this year's prediction, IMD has predicted and has projected that the monsoonal season, that is from June to September, the rainfall is likely to be around 99% of the long period average, with a kind of an error scope of around plus minus 5%. Now, 99% of the long period average means what? That over a period of these 4 months, we are going to receive almost this much amount of rainfall. Now here, we have to understand that based upon what criteria these particular categories, such as normal, above normal, etc., they are generated. So if you take a look at it, then if we have close to around 96 to 104% of rainfall as compared to the long period average, then that year is projected to have received normal or near normal rainfall. In case the rainfall received is only 90 to 96% of long period average, that brings about a below normal rainfall. Now, in the case of normal rainfall, you have to notice that it can be even slightly higher than the long period average. It does not necessarily have to be less than the LPA. So many of the times, even when the prediction and the projection is for the normal rainfall, we end up receiving, let's say, around 104%, 105%. Still, it is considered as normal rainfall. Now, above normal, it is basically a depiction of 104 to 110% of the long period average. The year 2019 and 2020, in these years, India had actually observed above normal rainfall. Similarly, 90% of LPA is regarded as deficient, whereas 110% and more is regarded as excess amount of rainfall received. So this gives us an idea about the categorization which is done. But then, as I said, the Indian Meteorological Department in itself has downgraded the LPA, or the long period average of the rainfall which India is supposed to receive in one particular year. Now, if you take a look at it, then basically this long period average of 1971 to 2020 period, this long duration of almost 50 years, in this, India is expected to receive 87 centimeter of rainfall on an average for the entire country during the monsoon month. However, this has been differing. This has been reducing over a period of time. If you look at the earlier averages, then basically for the period of 1951 to 2000, the expected long period average rainfall was 89 centimeter. Whereas for the period of 1961 to 2010, the LPA was estimated to be 88 centimeter average rainfall. Now, you don't necessarily have to get into the data of it. You have to understand the broader parameter. And the broader parameter tells us that as of now, we are passing through a dry epoch or a dry era. And here again, Indian Meteorological Department makes it absolutely clear that since 1901 onwards, we have had successive dry as well as wet eras and wet epochs. However, if you consider, then India began a dry epoch in the 1970 to 1980 decade, and that has continued till now. It is only in this decade, that is up till 2030, that is from 2020 to 2030, where India is expected to reach the neutral stage again, and from 2030 to 2040 onwards, again we shall start receiving more than average rainfall, and our LPA or long period average shall again start to increase. If you look at the chart of it, and the description and the depiction of the amount of rainfall received, here again, you will notice the period of dry and wet spells. If you notice, then 1901 to 1911, we had a dry period. Then again, from 1911 onwards, all the way up till 1961, we had a wet epoch or a wet era. And then again, we are languishing in a dry epoch, which is supposed to continue up till 2030. Again, after that, this rainfall will come back into the positive territory. Now, season-wise variation in rainfall has also started reducing. If you look at the rainfall received during the months of winter, that is January to February, notice how the amount of rainfall has received or actually receded. And then again, in the pre-monsoon months, you will observe again that the amount of rainfall received has again decreased substantially in this decade. And that has been same even during the monsoon months and also during the post-monsoon months. If you compare it in the 50-year epoch from 1961 to 2010 and 1971 to 2020, there is a consistent decline in the amount of rainfall received by the country. Now, that brings to fore the importance of forecast. Because let us suppose, in an year we are supposed to receive less rainfall or reduced amount of rainfall. As a farmer, you should know about it. As a city planner, as an administrator, you have to know about it. Only in that case will you be able to make necessary adjustments and necessary requirements in order to fulfill the deficit of that rainfall. So that is why forecasting of Indian monsoon becomes very, very important. But then if you take a look at the past trajectories, here you get an idea about the different zones of the country. The northwestern zone, the central zone, northeastern zone, as well as the southern zone. Now here you will observe that the blue curve in all these graphs, they represent the prediction. And the orange curve, that represents the actual amount of rainfall. Now, you will be stunned to know that in none of the years have these prediction and the actual amount of rainfall received coincided significantly. There is always a sign of variation. And similarly is the variation in the prediction of the onset of monsoon. Here, you look at your screen, you will find a map which tells you that the expected day for the onset of monsoon in any part of the country and the actual day when the Indian monsoon actually reaches that area. So you will find a slight variation almost existent throughout the country. Even in the year 2020, this was the case. Even in the year 2021, this has been the case, where there has been a significant variation. So why is it that the prediction is never actually able to match the actual onset of rainfall? Is it because we don't have enough number of good equipments? Is it because our prediction model is not so good enough? No. The answer to that lies in the fact that onset of Indian monsoon in itself is dependent upon a host of various different atmospheric and climatic conditions which keep on going across the globe. Out of all the various factors which are responsible for the onset of Indian monsoon, 3 of them are particularly very important, without which the onset of monsoon does not happen. That is why every year you will find the prediction that in this year or XYZ year, the monsoon and the onset of monsoon in Kerala is supposed to happen on 1st of June. 5 days after or 5 days later, another prediction comes in that the monsoon is going to be delayed by 1 week or monsoon is going to be early by 5 days. So this kind of variation is actually controlled by 3 major factors. What are those major factors? The first factor is subtropical westerly jet stream. The second factor is the shift in the ITCZ or the intertropical convergence zone. And the third factor is the storms or the tropical cyclones which end up developing in the Bay of Bengal and the Arabian Sea. Let us briefly take a look at all these factors and let us try to understand how these factors end up influencing the onset of Indian monsoon. Starting with the first and the most important factor without which the onset would not happen at all, and that is the subtropical westerly jet stream. Now, what is this jet stream? So, subtropical westerly jet stream is the jet stream which is prevalent in the upper altitude around the subtropics. Where is it present? So, it is present at the convergence zone of the Hadley cell and the Ferrel cell in the region of the tropopause. So, if you notice, then here you have, let us assume, the Hadley cell, and then let us assume you also have the Ferrel cell. So, at this zone of convergence, right, in the subtropics, that is where this subtropical westerly jet stream is in existence. Now, why the name westerly? Because its general direction of flow is from west to east. Now, this jet stream actually flows in the tropical and the subtropical area. So during the winter season, when all the pressure cells, they shift to the south, closer to the southern hemisphere, this subtropical westerly jet stream also does have a shift in the southward direction. But then this jet stream, as it comes in a wavy manner, as it approaches the country in a wavy pattern, thereby it encounters a kind of a physical obstruction. The obstruction is in the form of the mighty Himalayas and the Tibetan highlands. Now, this jet stream, upon looking at this and upon encountering this physical barrier, cannot simply override that physical barrier. Instead, this jet stream gets bifurcated into two parts. You have a northern branch and you also have a southern branch of jet stream which comes into existence and later on ends up joining together. Now, because of this southern branch of jet stream, we do not have the onset of Indian monsoon. So, this southern branch of this subtropical westerly jet stream, that does pass through the northern part of the country. If you look at this satellite image of the jet stream, you will get a better idea about how this jet stream eventually diverges into two parts or bifurcates into two parts due to the presence of the physical barrier in the form of Himalayas. Now, slowly as the months of March, April and May come in, the Indian subcontinent starts getting heated up. So automatically, this heated portion creates low pressure areas. So that means that monsoon winds or winds carrying moisture, they shall automatically be approaching the Indian shores, both from the region of Bay of Bengal as well as the Arabian Sea. But none of them will be able to bring rainfall because these winds won't be able to rise because of the barrier in the upper atmosphere presented by the southern branch of this westerly jet stream. Slowly and steadily, this southern branch starts getting weaker and weaker day by day, whereas the northern branch starts getting stronger and much more stronger. Eventually, a day comes when the southern branch completely disappears. And that is the time, that is the moment when all the winds with full force and full might, they hit up the land. And that is what brings about the onset of Indian monsoon. Unless and until this subtropical westerly jet stream, the southern branch of this jet stream, does not disappear, it will not happen. And it does not disappear with a kind of a prediction. It starts getting weaker and weaker day by day till eventually it stops being present altogether. So that is what is very important for the onset. Then the other part and the other important portion is the shift in the intertropical convergence zone or the shift in the ITCZ as we know it. Now this ITCZ or Intertropical Convergence Zone is that zone or that region around which the tropical winds from both the northern and the southern hemisphere, they end up meeting each other and thereby rising up. This ends up representing one of the lowest low pressure area or the most significant low pressure area present in the equatorial region of the country and also across the globe. So if you take a look at this ITCZ, during the month of January, when we have winter season in the northern hemisphere and summer season in the southern hemisphere, ITCZ is pretty much to the south of equator. But again, during the months of March, April, May, as the land starts getting heated up across the country, the ITCZ shifts north. And this is the actual presence of ITCZ during the month of July, which would mean what? That tropical winds, even from the southern hemisphere, would enter India. And this is the general wind direction observed during those months. During those months, you would observe and look at the wind direction. Observe how the winds, the southeasterly trade winds, they are approaching the equator. As they cross the equator, they change their direction. Why do they change their direction? Because of the influence of the Coriolis force. Because of the Coriolis force, any wind which is moving, or any moving object for that matter, in the northern hemisphere, it tends to bend towards the right, whereas in the southern hemisphere, it bends to the left. So that is why these winds, as soon as they cross the equator, they end up bending to the right. Now, it is these winds which would have crossed thousands of miles across the water bodies. They pick up significant amount of moisture. And when these winds hit the coastline and hit the land, that is when they bring ample amount of rainfall. So more powerful these winds are, more rainfall shall be received by India during the monsoon months. However, due to some reason or the other, if let's say this wind in itself becomes very weak, then you have lesser moisture being carried over to India, means lesser rainfall received by India, especially during the monsoon months. Now, these winds, they are driven around from the high pressure cells which are found and are formed in the southern part of Indian Ocean. This high pressure cell is what is also referred to as mascarene high. So it is from this mascarene high that these winds are driven. So stronger this high pressure, more winds will be driven. More winds being driven means what? More moisture will be carried by them. Why? Because they are covering the land, or they are covering the vast regions across the Indian Ocean. They pick up more moisture, and then when they hit the land, they will bring ample amount of rainfall along with them. Now, there is another factor which actually does influence the onset of monsoon. And this is a factor which has been in occurrence in the past few years. And that is the development of tropical storms or tropical cyclones. Now we know that tropical cyclones end up developing over the region of Bay of Bengal as well as over the region of Arabian Sea. In the past couple of years, we have been observing development of simultaneous storms or cyclones over Arabian Sea as well as the region of Bay of Bengal. Now these cyclones, what they end up doing is, they develop a cyclonic circulation of air, and at the same time, there is enough amount of moisture which is extracted, and that moisture is brought out in the form of rainfall. But then, imagine in the month of May, that is 1 month prior to the onset of monsoon, if moisture has been sucked out by these tropical storms, that means there will be lesser amount of moisture available by the winds and with the winds to cause rainfall during the monsoon months. So that is why onset starts getting delayed and starts getting affected if you have development of tropical cyclones either in the Arabian Sea or in the region of Bay of Bengal, especially during the months of April and May. During these months, if a cyclone is formed, onset is slightly delayed, and onset also starts becoming less effective and less impactful. So these are the various factors based upon which onset is dependent. This is the reason why, despite knowing all the various parameters which can influence the Indian monsoon, meteorologists and scientists, they are unable to come to a fixed date that monsoonal rainfall will happen on this date itself. Why? Because they are not sure when the subtropical westerly jet stream will disappear. They are not sure about the strength of the ITCZ, and also you cannot determine whether a tropical cyclone will be formed definitely or not. That is why there is a variation in the prediction of onset. As of now, as of today, the onset is being predicted to hit the Kerala coastline on 1st June. So, as of now, the onset is predicted to be normal. But follow the news cycle. You will automatically come to know whether the onset has been delayed or the onset has been early. Now, onset of monsoon gives us an idea about the rainfall received during the months of June, and in some parts of the country even during the months of July. But then, the rainfall received during the months of June, July, August and September, that is not always dependent on the onset. In many years, we have had almost a natural and normal onset of rainfall, but then during the later months of August and September, and also in the month of July, there has been a wide variation as compared to the projection and the prediction. So the overall rainfall, that is going to be the same. But the month-wise distribution, that can vary so significantly that, as we observed in the year 2021, you had excessive amount of rainfall received, especially in the central parts of the country during the month of September, which caused unseasonal floods as well as large-scale destruction of many of the crops, which were almost on the verge of getting harvested. So now, very briefly, we shall take a look at the factors which influence the monsoon rains and the monsoonal rainfall. So there are a host of factors which end up determining the amount of rainfall received after the onset. And what are these factors? So you have the El Nino cycles, the El Nino, La Nina and the neutral phase cycles, which develops in the Pacific Ocean. Then you have the condition of the Indian Ocean dipole. That is the difference in sea surface temperature across both ends of the Indian Ocean. Then you also have a circulation which is referred to as the Madden Julien oscillation. And we also have the tropical easterly jet, which sometimes does strengthen the monsoon, brings more than adequate rainfall during the month of July and August. You also have the factor of the monsoon trough, or the ITCZ in itself, moving during these monsoon months, leading to a variation in the amount of rainfall received. So all these various factors together are at play. It is not as if one individual factor is at play. Each one of them can have a counteracting effect on the other factor. And all of them together bring about a variation in rainfall. Now, when we talk about the ENSO cycles, or the El Nino southern oscillation cycles which develop in the region of the Pacific, now this has got three phases. It has got either a neutral phase, which is also referred to as the neutral condition. Now, under this neutral condition, what happens? You have basically warm waters which accumulate in the region of the Western Pacific under the influence of trade winds. So that brings about low pressure condition in the region of Western Pacific. And that sets in motion a circulation in the atmosphere which is dependent upon the temperature of the ocean. Now observe here. You will observe that here you have the low pressure, so the air is rising. And this air descends where? It does descend in the region of Mascarene High, strengthening the Mascarene High. So neutral conditions would mean ideally normal rainfall in India. Especially during the monsoon months, it means normal rainfall received in India. But then, slowly and steadily, these neutral conditions, sometimes they strengthen, as you can observe with the help of this animation, that sometimes these neutral conditions, they strengthen significantly. Meaning what? Meaning, the area where the warm water is present, that area starts increasing. And also, the accumulation of warm water is very, very significant. So that intensifies the low pressure in the region of Western Pacific. And that ends up creating a condition of La Nina. During La Nina conditions, what do we have? A more strengthened neutral condition. And neutral condition brought normal rainfall to India. La Nina condition brings above normal or excess rainfall to India. This is the reason why 2019, 2020 and 2021 India ended up receiving close to around 107 to 110% of the long period average of rainfall. Why? Because we had La Nina conditions prevalent in the Pacific. So La Nina condition is also a very good sign for Indian monsoon because it brings above average rainfall in the country. Okay? But then the conditions become dicey when this is reversed and you have the low pressure formed in the region of the Eastern Pacific, and that is the condition of El Nino. Now observe that during El Nino, while the winds they rise up here in the Eastern Pacific, here in the region of the southern part of Indian Ocean, the mascarene high is weakened because here also you have a rising air column. Whereas in the neutral conditions observed that this brought about a strengthening of the high pressure in the mascarene high, meaning you had greater rainfall received in India. Because if mascarene high is stronger, means what? More winds are driven towards India. But in this case, in the condition of El Nino, observe how the mascarene high pressure gets weakened, and as a result of that, India ends up experiencing dry, drought-like conditions or a general deficit rainfall. Okay, so you have drought-like conditions during monsoon. Why? Because of a significant amount of deficit in total rainfall. So El Nino conditions, they are never good for the amount of rainfall received during the monsoon months. Here in the chart you can observe that across various years, whenever you had a condition of El Nino, India always experienced less amount of rainfall. So look at 1997, we had a very strong El Nino. But then India received near normal rainfall as compared to the LPA. Why? Because of the influence of Indian Ocean dipole. But other than that, El Nino always refers to a deficient rainfall. Whenever you have El Nino, there is a deficient rainfall. In 2009, when we had a moderate El Nino, we were hit by severe drought-like conditions. So these El Nino and La Nina predictions, they are very, very important in telling us about the amount of rainfall received. This year's prediction basically tells us that La Nina conditions are going to be prevalent. So for the month of March, April, May, the La Nina conditions are going to be prevalent. Then these La Nina conditions, their prevalence and their probability is going to decrease as we move ahead in the month of August, September and October. But at the same time, observe how the neutral forecast probability, that is on the rise. But then we have seen that even if it is a neutral condition, India does receive normal rainfall. So even if we don't receive excessive amount of rainfall this year, at least we will receive normal rainfalls this year. Having said that, it also depends upon the condition of the Indian Ocean. Now that brings us to the important factor contributing to the amount of rainfall received in India during the monsoon months, and that is the Indian Ocean Dipole. Now what is this Indian Ocean Dipole? Now as the name in itself tells you, this is nothing but a difference in sea surface temperature across the eastern and the western part of the Indian Ocean. Now based upon that difference in sea surface temperature, a low pressure and a high pressure region is created, and that brings into effect an atmospheric circulation. It is also referred to as the Nino of Indian Ocean, because even in the Pacific, a similar condition is observed which leads to La Nina, El Nino and neutral conditions. Here also, similar circumstances are observed. Now, just like in the case of Pacific, here also you have a neutral condition for IOD, you have a negative condition of Indian Ocean Dipole, and you have a positive condition of Indian Ocean Dipole. Now, what is the neutral condition? Neutral condition is when the sea surface temperature across the region of the eastern Indian Ocean, when the sea surface temperature is slightly higher, that creates a kind of a low pressure. And that brings about rainfall in the region of Indonesia, but then that also deviates and attracts winds from the mascarene high. So lesser number of winds then approach India, and that brings about a deficit in rainfall. So under neutral conditions of IOD or neutral phase of Indian Ocean Dipole, we experience slightly lesser amount of rainfall. Slowly and steadily, if this neutral phase intensifies, this low pressure intensifies, and we have a negative phase. Now, negative phase means what? The low pressure in the eastern Indian Ocean is very, very intense. Meaning what? Meaning it will attract more winds from the region of mascarene high. All those winds which were supposed to reach India, they will be diverted to the eastern Indian Ocean. So both these, they lead to reduced rainfall during monsoon months. Both of these parameters. Now, interestingly, this year, even though the prediction of La Nina is quite favorable, that either we will have La Nina conditions in this year of monsoon or normal conditions, which brings about slightly above average amount of rainfall. But then, in the later part of the year, that is in the month of July, we are expecting the neutral phase of IOD to come into existence. And that means the rainfall will be slightly deficient and variable in the months of July, August. So that tells you that even if the onset is regular, the rainfall can be deficient and can be variable in the later period of the monsoonal months. The only condition of Indian Ocean Dipole which is favorable for Indian monsoon is the positive phase of IOD. And the positive phase of IOD ends up creating a low pressure which is very similar and concordant with the ITCZ which develops over the Indian subcontinent. So this will attract winds and channelize it to the ITCZ, which brings about ample amount of rainfall, and this brings about above average rainfall. Now, for the examination perspective, by the way, you as a candidate are not supposed to, if you are studying only for general studies, UPSC does not ask the exact reasons why you receive less rainfall during the negative IOD or the neutral IOD, why India receives more rainfall during the phase of positive IOD. Minimum thing that you have to know is that when is it that India receives more rainfall. Now, if you notice the kind of chart that we had observed regarding the monsoonal rainfall, then In 1997, even though we had a month or year of very strong El Nino, one of the strongest in the previous century, India received above average rainfall, 102% of the LPA. Why? Because we had the positive IOD. So positive IOD always brings about an increase in the rainfall received. Now, variation in the rainfall received during the monsoon months is also brought about by an equatorial circulation, which does happen across the globe, and that is what is referred to as Madden-Julien oscillation. Madden-Julien oscillation is nothing but a kind of a cross-equatorial circulation which does travel across the planet just like a conveyor belt system, and thereby it has got two portions or two components. As you can observe here, this will have two components or two portions. You will have a phase or a component of low pressure, and then you will have high pressure around it. So depending upon the placement of this Madden-Julien oscillation, if suppose this low pressure region lies over the area of Arabian Sea, that would mean increased rainfall received in India during the monsoon months. But then this is a very transient phenomena, very temporary phenomena. This phenomena of oscillation does cover the whole planet between 30 to 60 days. So that tells you that this low pressure is not going to remain in the same place for more than 5 to 7 days. But then, if it lies over the region of Arabian Sea during the months of June, July or August, means improved rainfall received in India during the monsoon months. However, in this year, MJO has still not started forming, and MJO is not supposed to take a major role in influencing the monsoon as of now, as of the prediction generated now. Another prediction will be generated at the end of May as well by the Indian Meteorological Department. So maybe at that point of time, we might get to know that yes, there has been heating of the African continent and a low pressure is formed there. But as of now, MJO is not supposed to be a major player in influencing the Indian monsoon. If suppose this low pressure of MJO lies somewhere across the eastern part of Indian Ocean, then it will play the same role that the negative Indian Ocean dipole played. It will reduce the amount of rainfall received by India. Now, these factors, along with another major factor, that is the tropical easterly jet, that determines the amount of monsoon winds or the strength of monsoon winds which are driven towards the Indian subcontinent. Now, tropical easterly jet, what is it and why is it generated? So it is primarily generated because of the highest plateau across the globe, and that is the Tibetan highlands. Now, Tibetan highlands on an average have an altitude of close to around 5,000 meters from the sea surface. During the summer months, that is during these months of April and May and first part of June as well, the Tibetan highlands will start getting heated up. Now, as this starts getting heated up means what? Air will start rising up from here. Now, in the upper atmosphere, the air will diverge in all directions, right? It will diverge in all directions. Now, one of these components, they drive down from the region across India in the upper atmosphere, gaining a speed of almost 90 to 100 kilometers per hour. And they move in the upper atmosphere from the region of India all the way to Africa. And then they fall, they sink, and then after they sink, after that they move as surface winds over to the Indian coastline. So the normal logic tells us that more winds which are driven from the region of Tibetan highlands means what? More winds will sink in the region of Indian Ocean and they will carry more moisture and bring more rainfall to India. So heating of Tibetan highland and generation of tropical easterly jet is another very important phenomena contributing to the amount of rainfall received. Stronger the tropical easterly jet, more will be the winds driven from the Indian Ocean towards the Indian subcontinent and more will be the rainfall received by India. Weaker the tropical easterly jet, lesser will be the amount of winds driven towards India. And this tropical easterly jet is dependent upon what? Heating of Tibetan highlands. So let us assume in one particular year, let's say 2021, Tibetan highland was not covered with snow to that extent. And the melting of snow was completed in the months of April itself. So in the later part of April and May, the Tibetan highland will start getting heated up and more air will start rising. And the tropical easterly jet will be very strong. But if you assume that in the previous year the snow cover was very, very thick, so Tibetan highland won't heat up to that extent in the coming season, and this tropical easterly jet will be weaker, thereby meaning lesser rainfall during the monsoon months. So this has got a direct proportionality with the amount of rainfall received. If this is stronger, the easterly jet is stronger, means more rainfall will be received. But then, all these factors, they are all playing with the positioning of the ITCZ or the monsoon trough over the country. If you observe the figure, here you will observe this being the natural and the normal position of the monsoon trough or that low pressure region which will attract winds from Arabian Sea and the region of Bay of Bengal. This extends all the way from Pakistan to Bay of Bengal. Now under these conditions, rainfall will be distributed and moisture carrying winds from the region of Arabian Sea as well as the region of Bay of Bengal, they will be driven and you will have rainfall received in Odisha, Chhattisgarh, West Bengal, Jharkhand, Bihar, UP, MP and so on. But then this low pressure region does not stay at its place. It can sometimes shift north, sometimes it can shift south. Why does it shift north and south? Depending upon how much heating of land mass has happened during the summer months. Sometimes what happens, the foothills of the Himalayas, the northern part of UP, Bihar, western part of UP, Delhi, all these areas, Punjab, they get very, very heated up. So the low pressure region actually shifts north in the region of the Himalayas. So that would mean that the monsoon winds are driven over and attracted to the region of foothills of Himalayas. But then across the entirety of the country, you will have a deficit of rainfall. So a northward movement of this monsoon trough means a deficient rainfall across the country. However, as was the case in September 2021, sometimes this monsoon trough, it shifts southward and covers the central part of India as well as the peninsular region. So in those conditions and during these phases, you have a sudden increase in rainfall received over the central and the peninsular part of the country, many of the times also leading to unseasonal floods. Remember, if you are able to recall, then previous year in the month of September, you had floods which had occurred across the region of Maharashtra, Karnataka, Andhra Pradesh and some parts of Madhya Pradesh as well. And that was because this monsoon trough that had shifted slightly south. So all these factors, they have to come together. They are at play together. And that is what influences the amount of rainfall received. It is not only influenced by one factor in such. Now, why is it that we are so concerned about the variation in the rainfall received? variation or variability in the amount of rainfall received, especially during the monsoon months, can have a host of different impacts over various parts of the country. So if you look at it, first of all, the major part that we have seen, agriculture and economy, they are hit the hardest. The deficit months or the deficit years of monsoon, the economy suffers, the agricultural output suffers significantly, the farm income reduces, brings about rural poverty. Rural poverty also brings about a greater sense of social disparity as well. So the society gets impacted. But then these unseasonal rainfall, that brings about floods and droughts in various parts of the country. You will be surprised to know that even though we have been receiving average and above average rainfall, the northeastern states of the country, they have been receiving deficient rainfall almost every year. And the amount of rainfall received in the northeastern states, that is reducing drastically, which is very, very destructive and devastating for the local flora and fauna and also for the local biodiversity. At the same time, the region around western Madhya Pradesh, Rajasthan, Gujarat, eastern part of Maharashtra and Telangana, they have been receiving unseasonal rainfall and excessive amount of this unseasonal rainfall because of this variability. And that is why many of the urban areas in those regions are suffering from floods. Now, this can be tackled, this can be taken care of, provided we are able to forecast this beforehand. Only then the district administration, the farming community, the FPOs, all of them can make necessary arrangements in order to fulfill that lack of water availability or excessive amount of rainfall which is supposed to happen. You have to make prior arrangements of that. And how do you do that? By installing more radars, better Doppler radars, which gives you an exact idea about how much rainfall will be brought about by a particular cloud pocket. As of now and even today, the rainfall prediction which is carried out by the Meteorological Department is very, very vague. So while the prediction models need to be improved, the infrastructural improvement also needs to happen. And that is why India is partnering with many, many countries in order to understand the phenomena of heating of Pacific, Atlantic, all of them in a better manner. So, overall, now we have understood what these monsoons are. We have understood the factors dependent on which and based upon which the onset of monsoon is dependent and is variable. We have seen why it is so difficult to come up with the exact date when there will be the onset of Indian monsoon. We have also seen that despite having a normal onset, we still have many factors which are at play, which can bring about a variation in the rainfall received during the monsoonal period of June, July, August and September. These months, they bring about close to around 75 to 80% of the rainfall received by the country throughout the year. So it won't be an overstatement to say that these 4 months, they are the lifeline of the country, and having a better forecast is the need of the hour. Now, all these things that we have looked upon, these are very, very important, especially for your prelims examination. Every year, necessarily, you will find one question appearing from these topics. And all that you need to know being a candidate is the impact of a particular phenomena on the incident of Indian monsoon, and that shall be more than sufficient, provided you are keeping yourself up to date to the next future predictions given by the Indian Meteorological Department. If you just follow the Indian Meteorological Department in the coming days, in the next 1 month, you will come across another kind of this prediction, and then you will be able to correlate whether a Madden Julien oscillation is setting in, whether that neutral phase of Indian Ocean dipole is actually strengthening into a negative phase, and how that is going to impact the rainfall or reduce or increase the rainfall. Overall, that is all that you need to know from this topic. Thank you.